Day 625 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. In the day, we have question number 1895, largest magic square. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. A K by K magic square is a K by K grid filled with integers such that every row sum, every column sum, and both diagonal sums are all equal. The integers in the magic square do not have to be distinct. Every 1 by 1 grid is trivially a magic square. Given an n by n integer grid, return the size, i.e. the side length of K, of the largest magic square that can be found within this grid. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So, in example 1, we have our input grid equals a 2D array of integers. First array 7, 1, 4, 5, 6. Next array 2, 5, 1, 6, 4. Next array 1, 5, 4, 3, 2. And the last array is 1, 2, 7, 3, and 4. Now, before we go any further, I just want y'all to remember that each row represents, or excuse me, each array represents a different row. So this is the top row, this right here is the second row, this right here is the third row, and this right here is the fourth row. Boom. With that input, the output is 3 because you can see our magic square right here highlighted in red has a length and width and height of 3. So it's 1, 2, 3 width, 1, 2, 3 height, right? And I mean, since it's a square, the height and the width will be the same. So this has a width of 3, height of 3, so the output is 3 because it's a square. Explanation says the largest magic square has a size of 3. It says every row sum, column sum, and diagonal sum of this magic square is equal to 12. So if we add every number up here in this row, that gives us 12. Every number in this row, that gives us 12. Every number in this row gives us 12. Thus, the row sums, boom, 12. Column sums, every column, or this column, every number in this column equals 12. Every number in this the sum of this column is 12. The sum of this column is 12, and the sum of this column is 12. Boom. So that's this right here. Then the sum of this diagonal is 12, and the sum of this diagonal is 12. Boom, that's this right here. And since all of them equal 12, or each row has the same, each row has the same sum, each column has the same sum, and each diagonal, since they all have the same sum, that makes this a magic square. The size of the square is 3, once again, so that's why the output is 3. Now, just in case that didn't make sense, let's take a look at example 2. Example 2 is a little easier because all of the numbers are the same. So, in example 2, grid equals a 2D array of integers. First top row is 5, 1, 3, 1. Middle row is 9, 3, 3, 1. And the bottom row is 1, 3, 3, 8. Boom. This is the magic square right here. And then the output is 2 because it has a length, has a length of 2 or width or height of 2, however you want to look at it. So boom. Now that we understand the question, y'all, let's get into the fun part, the actual solution. The solution is not that difficult at all. It is a little bit lengthy, so make sure you pay attention as we go through it. Now, the first thing we want to do is we are going to say, we're going to say let m equal grid.count. Boom. Then we're going to say that's going to get us the rows. Then we're going to get the columns by saying let n equal grid square bracket 0 dot count. Boom. Then our prefix sum for rows, we're going to declare a variable called row sum. Set that equal to, it's going to be a 2D array. So we're going to say array, open up the parentheses, repeating, colon, it's 2D array of integers, so it's going to be repeating another array. We're going to open up the parentheses again. This time we're going to say repeating colon 0, comma, count, colon, n, come outside of these parentheses, or excuse me, this should be n plus 1, come outside this parenthesis, still inside the other, and we're going to say count, colon, m. Boom. Then we're going to get the prefix sum for column, so we're going to declare a variable called call sum. Boom. And this is going to be equal to, we could really just copy and paste this, but we're going to change some things. We copy and paste this right here. Boom. But we're going to change this n plus 1 to just n, and we're going to change this m to n plus 1, and that's for the columns. Boom. Now we need to build the prefix sum. So we're going to say for r n 0 dot dot less than m. We're going to open up the brackets. Then we're going to say for c n 0 dot dot less than dot dot less than n. Then we're going to open up the brackets. Boom. Then we're going to say row sum square bracket r, come outside of that, square bracket c plus 1. We're going to set that equal to row sum square bracket r, square bracket c plus, equal white space, plus grid square bracket r, square bracket c. Boom. Then we're going to come underneath this, do the same thing. We're going to say call sum square bracket r plus 1, come outside of that, square bracket c. We're going to set that equal to call sum square bracket r, square bracket c, plus grid square bracket r, square bracket c. Boom. Now we're going to create a helper function to check if a square within the top left or row column and in size k is magic. So we're just going to check if the square is magic. So we're going to come right here underneath this for loop. We're going to declare func. It's going to be called is magic. We're going to open up the parentheses. We're going to say underscore r colon. That's going to be integer, comma, underscore c colon. That's going to be integer, comma. Then we're going to say underscore k colon. That's going to be an integer. And we're going to come outside of this and we are going to return a boolean. Boom, open up the brackets. Now the target sum is the first row of the square. So we're going to say let target equal row sum square bracket r, come outside of that, square bracket, this time we're going to say square bracket c plus k. Then we're going to come outside of this and we're going to say minus row sum square bracket r, square bracket c. Boom. Boom, boom. Then we're going to check all rows in the square. So we're going to say for I and 0 dot dot less than k. We're going to open up the brackets and we're going to say let sum equal row sum square bracket r plus I. Come outside of that. We are going to say square bracket c plus k. We're going to come outside of that and we're going to say minus row sum square bracket r plus I. Come outside of that, square bracket c. Boom. Then we're going to come underneath that. We're going to say if sum does not equal target, then we'll open up the brackets and we can return false. Now we're going to check all columns in the square. So we'll come underneath this and we are going to say for j and 0 dot dot less than k. We're going to open up the brackets and we're going to say let call sum square bracket r plus k. Come outside of that. We are going to say square bracket c. Square bracket c plus j. Come outside of that. We're going to say minus call sum square bracket r. Come outside of that. Square bracket c plus 1. Boom. Oh, excuse me, not c plus 1. C plus j. Boom. Then we'll come underneath that. And we're going to say if sum does not equal target, Then we can open up the brackets and we can return false. Boom. Now we need to check the main diagonal. So we're going to come underneath this for loop, declare a variable called diag. We call it diag1. So we'll say var diag1. We'll set that equal to 0. Then we'll say for I in 0 dot dot less than k. Open up the brackets. We'll say diag1 plus equals grid square bracket r plus I, come outside of that, square bracket c plus I. Boom. Then we can come underneath this and we can say if diag1, sorry y'all, if diag1 does not equal target, then we'll open up the brackets and we'll return false. Boom. Then we'll come underneath this. We're going to check the anti-diagonal by coming underneath this, or the opposite diagonal, and we are going to declare a variable called diag2, set that equal to 0. Boom, and we're going to say for I in 0 dot dot less than k. We're going to open up the brackets and we're going to say diag2 plus equals grid square bracket r plus I. Come outside of that, say square bracket c plus k. Sorry y'all, minus 1. Sorry y'all, minus I. Boom. Then we'll come underneath this for loop right here and we'll say if diag2 does not equal target, then we can open up the brackets and we can return false. Boom. Then we'll come underneath that. Sorry, y'all. Come underneath this and we could just say return true. Boom. Now we're going to try square sizes from largest to smallest. So we're going to come underneath this right here, outside of this helper function, and we are going to say, I think that's outside the helper function. Yep, outside of the helper function, we're going to say for size in stride, open up the parentheses, from square bracket min, open up the parentheses, m comma n, come outside of that, comma, through, colon, 2, comma, by, colon, -1. Then we are going to come right here. We're going to open up the brackets and we're going to say for r in 0 dot 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 m, m minus size. Boom. We're going to open up the brackets. Then we're going to say for c in 0 dot dot dot. Sorry, y'all. For c in 0 dot 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 n minus size. Then we're going to open up the brackets and we're going to call our helper function by saying if is magic, open up the parentheses, r comma c comma size. Then we're going to come outside of that, open up the brackets, and we'll return size. Boom. Now if any cell is now if it's a single cell that is that we need to handle the case if it's a single cell. Sorry, y'all. If it's a single cell, we need to handle that, right? For this trivial magic square, right? We could handle that by, we could just come right here. And if this runs without returning anything, then we could come right here and we could just say return 1. Boom, y'all. So let's go ahead and give this a run before we submit it. Make sure it runs properly. Okay, so let's see. We got an error. See where it's at. See, okay, equal white space, y'all. Equal white space. Let's run it again. Okay, now let's see what's going on here. Let call some. Let me see, y'all. Just a minute. Just a minute, y'all. So this, let me Let's see. Let's see, y'all, what's going on here. Hold on, y'all. Sorry about this. What is going on? Oh, okay. I didn't say this should be let sum equal call sum. Boom. Let's see if that does the trick. Hopefully that does the trick. Okay, that did the trick. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top. This is the middle. And this is the this is the bottom part of the middle. This isn't the rest of it. This right here is the rest of it, y'all. And with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.